Okay, this next video, this is Mock Exam Review 2016-20, Electrical Engineering Fundamentals. In this next question, we're going to use the diode as a rectifier. The job of the diode is to remove the negative part of a sine wave voltage. It will remove this because when the voltage goes negative, the diode is reverse biased and it will not conduct current. And because it will not conduct current, it will not create a voltage drop across the load resistor, which means the voltage measured across the load resistor will only show voltage conducting in the positive direction. Now, the key word is ideal. If you have an ideal diode, we're assuming that when the diode is forward biased, there will be 0 volts across the diode. And when the diode is reverse biased, all the voltage from the power supply will be across the diode, which means that we will ignore the 0.7. However, the opposite of ideal is practical. And when we use a practical silicon diode, then we have to consider the 0.7 volts. In this example, it's asking us for the ideal, which means we will not use the 0.7 in this calculation. So here it says determine the average current through RL in the circuit. Well, V average formula is equal to the peak voltage divided by pi. Please note that this is not the same formula that's given on the formula sheet. On the formula sheet, V average is given as 2 times V peak over pi. That is because it is not considering the negative part. It is assuming that you have a wave that looks like this. That's called full wave rectifier, where there is voltage on the positive cycle and there's voltage on the negative cycle. But for half wave, there's only voltage on the positive cycle, which means we will not be using the 2 in the formula. So we need to find out the peak value in order to complete this calculation. Well, the other formula is VRMS is equal to the peak value divided by the square root of 2. Which means that if we have the RMS value, then we can calculate the peak value by multiplying by square root of 2. All right. If we take the peak value and you multiply by the square root of 2, in this problem, you get 311 volts. So now we have enough information for us to calculate the average value. If we have 311 volts and we divide that value by pi, which is 3.14, we get 99 volts of RMS, or average voltage, across RL. Now the last calculation is Ohm's law. I is equal to V divided by R. So now, if we have 99 volts, and we divide that by the 50 ohm resistor, you will calculate 1.98 as your final answer. I believe on your paper it reads 1.98. If it does not, then scratch out the 3.96 amps and write down 1.98 as your solution, because that is the correct answer, 1.98 amps for this problem. Thank you.